Stat students. Today we're talking about displaying quantitative data. In the last video we talked about displaying categorical data and summarizing categorical data. And in this one, again, we're going to look at the two major pieces of data analysis, that is summarizing and illustrating data. Okay? So first let's look at summarizing. With categorical data, there wasn't much to the summary. It was basically what percentage falls in this category, what percentage falls in this category, what percentage in that one. With quantitative data, there's actually a lot more to look at, because now we have numerical values. And so now we can say, well, all of these values that what we're looking at, are they, like, where's the center of the values? Meaning, yeah, like the average, okay? What's the spread? Are they spread way out? Is there a lot of variety? Or are they all bunched around a single value? By shape and unusual features, I'll show you what I mean in a second about that. By the way, if these terms seem kind of vague right now, that's okay. We're going to be more specific in the future, so don't be bummed out by that. Okay? Now, how do we illustrate? Oh, by the way, first, before I get to that, a lot of times people forget, oh, what is it? What are those things I'm supposed to check for? Center, spread, shape? Well, if you put them in a different order, and say center, unusual features, spread, shape, that way you can remember the mnemonic device CUSS and just think, okay, I need to cuss about this data, okay? All right, now, how to illustrate the data set? Well, we can use dot plots, we can use histograms, we can use stem plots, and sometimes, depending on the data set, we can use time plots. And we're going to look at all four of those today. All right? So, first off, the dot plot. Here is a dot plot. This is the median life expectancy at birth for 222 countries. And by the way, if you're wondering where I got this data, I got it from the CIA World Factbook online. Yes, that CIA. Okay? They're our national intelligence agency, right? They go out and they find a bunch of information, and some of it, not all of it, but some of it, they post online so that you can get information about different countries. And that's where I got this from. So each one of these dots represents a different country, and in particular, it represents the median life expectancy at birth for 222 for each country. So let's look at the lucky country. This one right here. I happen to know that this one's Monaco. It's a very, very tiny country bordered by France on all sides, and it's on the French Riviera. They've got a big casino there. And apparently people live a really long time there. So their median life expectancy is just under 90 years, which means at birth, half of their people live over 90 years, and the other half die before they hit 90 years. But still, that's a very high median life expectancy. Other countries don't have it that high. Looks like a whole bunch of our countries here fall between about 72 and 82. And then we have a few down here which seem to be having some problems. Now, what can we tell from a dot plot? First off, dot plots are really easy to make. Okay? You get two people, one is just listing out the numbers, and the other one's just drawing little dots there. It's really easy to do by hand, which is one of the pros of using a dot plot. And another good thing about the dot plot is you start to see, remember I said I would talk about the shape in a few minutes? You start to see the shape of the data set. Okay? And in particular, what I see here is, here's a mound here, okay? So that's one mode of our data. And then it looks like I might have another little mound here and possibly a third little mound there. So it looks like this particular data set might be multimodal, meaning I have different modes of my data. When you have multimodal data, what you should usually do is go back to your data and say, am I looking at distinct populations here? Perhaps in order to really analyze this data set, I need to break it up into smaller sets of data. And as it turns out, that's true here. Because these lower countries, not all of them, but almost all of them are African. In particular, sub-Saharan Africa, which is still really, really suffering from an AIDS epidemic. And they've got lots of other problems which bring down their life expectancy. And these really, really high life expectancy countries, the vast majority are European. So, that's one dot plot. And remember the four things, I did this, the four things, I can count, the four things that you're supposed to check for. The center of this data set would be, I'm going to say about 74 73, 74, somewhere around there. The spread goes from less than 50 to almost 90, so that's about 40 years. The shape, we said that most of our data is here, and then there's a tail going out there. The way to describe that is it is skewed to the left. Skewed to the left, meaning you got a tail moving out here to the left side. Skewed to the left, and we might have an outlier right there. An outlier is merely a data point that doesn't seem to go with the rest of them. Okay? It's way off to one side. Unusual features. Well, an outlier is an unusual feature, and the multi-modes, the distinct modes, might also be an unusual feature. Any gaps in our data set would also be, that's something that you want to take note of, and that would also be an unusual feature of our data. Okay? Here's another data set. This is from the same website. This is the youth unemployment rate for young people. And by young people, we're talking about 15 to 24-year-olds. Those young people who are looking for jobs, this is the percent of them that can't find jobs. Okay? It's a smaller set of countries. This one was 222 countries. This data set is 143 countries. It's what was available. And as you see, there's a whole bunch of countries down here where actually quite a few of them, almost every young person who wants a job can find one. Here's one very unfortunate country where almost 3/4 of their young people are unable to find work. But this data set, as you can see, the center appears to be about maybe between 15 and 20%. The spread goes all the way from 0 to 75%, so that's a 75% spread. Again, that's a very wide spread. This shape is skewed to the right. That's where the tail is pointing, is out to the right. And the unusual features that I would say, this guy is almost definitely an outlier, and these three here might also be considered outliers. In the next video, I'll give you a precise formula that you can use to calculate what we consider an outlier and what we don't. For now, let's just call it a weird data point. As far as unusual things, I mentioned the outliers. I'm not sure that would be considered another mode there. Okay? Here's another data set, yet another data set. This one has a fewer number of dots. That's because these are the public universities in Texas. I found the annual tuition for 38 different public universities in Texas, and this is in the thousands. So the smallest one here appears to be about $5,000, and the highest one is about a little over $11,000. This is just tuition, okay? No room and board included here, so don't get excited. As we see here, the center of our data set seems to be about $7,000. It ranges from 5 to 11, so it's got a range of more than $6,000. It also appears to be skewed to the right, but not as heavily skewed as this data set above it. It looks a little more symmetric than the last one, although I still wouldn't call this one symmetric. It still seems to be skewed to a certain degree. Okay? So those are dot plots. Now let's look at histograms. Okay? I left this dot plot up here so we can compare the dot plot to the histogram. This is the life expectancy data set. Now, each of these, it looks like a bar chart, right? It's not a bar chart. It's a histogram. Bar charts are used for categorical data. Histograms are used for quantitative data. Each of these bars here are called bins, B-I-N-S. A bin is usually something where you collect something. And what you can think of is these are all little collection bins. If you were to take all of your dots and just drop them into these bins, the height of the bin represents how many dots would fall into there. Okay? So this one, it only has one dot in it. That's because that's Monaco. All right? This one here looks like it has 3 dots. That would be these 3 dots right here. Okay? So each one is exactly the same width. Okay? And I actually find it easier to see the shape of the data set from the histogram than I do from the dot plot. Now I can look at this and I can see, okay, yeah, it does look like there might be another mode there, and it certainly looks like there might be another mode right here. So I would want to take this, this data set apart and look at the different components of it, and it might give me a better analysis that way. So that's the histogram of, oh, and by the way, please notice that with a histogram, you need to have a y-axis as well, okay? Your x-axis still has the actual thing that you're measuring, in this case it's the life expectancy, and your y-axis has the frequency of values there. So, like, I can tell this bin right here has about 10 data points in it, okay? This is the dot plot and the histogram of the youth unemployment rates of the countries. And again, you can see this one right here corresponds to this dot right here. That's our outlier. This right here corresponds to these 3 dots there. And now you can easily see, yeah, this is really skewed to the right here. Okay? And here are our tuitions. And again, you can see, yeah, okay, it's got a longer tail. Not hugely longer, but a longer tail going to the right. This is also skewed to the right. It's not horribly skewed, but it's a little bit skewed to the right. Now, you might be wondering, if I'm making a histogram, how wide do I make my bins? Well, there's no real rule about that. Because here's another histogram that represents the exact same data set, and if you'll notice, it looks a little bit different. It looks pretty similar, but there are some differences here. And the only difference is, I made the bins slightly narrower on this one. And so now, this guy looks a lot more like an outlier than it did over here, where it looked more connected. There's no correct answer about the correct bin width. Basically, it needs to be the width that kind of tells you the most about the data set. And I realize that's a very fuzzy definition, but that's the best I can do. All right, now let's look at stem plots. These are also called stem and leaf displays. I'm sure you've seen these in middle school. Here's our little rule here to tell us what it means. It means that these numbers on the left represent $1,000, and then the digits on the right represent $100. Okay? So this is the same data set. These are the public universities in Texas. Here's our expensive one. Here's our least expensive one. And you can get an idea of the spread and the shape. Well, the shape especially, just by kind of turning your head to the right here. You do want to be careful, though, because once you turn your head, the left side is going to be the bigger numbers, and the right side is going to be the smaller numbers, which is usually the opposite of how our histograms are. So if you wanted to turn this into a histogram, I guess you would you'd turn it around that way, and then you'd flip it around, and then you'd draw rectangles around there, and then you'd fill in those rectangles and fix your x-axis, and now you got yourself a histogram. Oh, and then you wouldn't want to call it a stem plot anymore. You'd want to call it a histogram. And now you're all done, right? So stem plots basically give you the shape just like a histogram would. Now, here are our, this is the life expectancy data again, and I'm looking at dot plots, histograms, and stem plots, these 3 different ways of displaying data. Except this time I've taken our life expectancy data and I've split it up. I'm just looking at a subset, actually 2 subsets of the data. I'm looking at Asia and North America. Asia and North America. Asia and North America. And in each plot, I've split them apart. And in each time, I've kept the same scale for both data sets. So you can see that the smallest point, the country with the lowest life expectancy, Haiti, by the way, in North America. It's North America, let me be specific. It's North America, Central America, and the Caribbean. Okay? That's why we have so many dots there. That's our lowest there. In Asia, sadly, the one outlier way over there on the left is Afghanistan, still a very, very troubled country. But this gives you some, now we see a lot of good information here. Let's focus on the histogram. I really like histograms. What does it tell us? Well, it tells us that the center of our North American data seems to be right around here, about 75, which is not that far off from the center of the Asian data. Maybe the center actually for North America is probably a little higher than the center for the Asian data. Asian is really spread out more than North American data. are the countries with the highest life expectancy in Asia actually are better than any country in North America. But we have several countries in Asia with a lower life expectancy than the vast majority of countries in North America. Again, if you were looking at the raw data, like from a table, you couldn't tell this. It's only when you illustrate it that you're able to get so much information. This data set, if you take out Afghanistan, appears to actually be quite symmetrical. Okay? Remember, when you're looking for symmetry in a data set, don't look for exact symmetry. Round it. Okay? It does look fairly symmetrical if you round out those rough edges. Whereas the North American one still looks like it might be a little bit skewed to the left. However, if we get rid of that outlier and maybe we get rid of that one, now it's looking a lot more symmetrical. Again, in a stem plot, this is a back-to-back stem plot. You can also see the same trend. Here you can see that there are a lot more countries in Asia with life expectancies in the 60s, whereas very, very few, only 2 countries in North America with median life expectancies in the 60s. So those are different ways of using these 3 different displays to compare data sets. Okay, now here's a brand new data set. This is the number of texts that I sent in the month of August. Well, actually, only half of the month of August. Going from August 15th to August 28th. And I never like to tell lies on YouTube. Let me just be very clear. This is made up. This isn't my real data, okay? I just made it up. So apparently on August 15th, the fictitious me sent 4 texts. On August 16th, I sent 7. On August 17th, I sent 8, etc., etc. Okay? And so I asked somebody, would you please make me a histogram of this data? And this is the histogram that was made. Okay? So as we look at this, here are the different dates going across here, and here's our y-axis showing the number of texts shown. So I'm looking at this and I'm thinking, okay, so let me see what the center of my data set is. And the center of my data set is August 21st or 22nd. That's not a number of texts. This isn't a histogram, okay? This is a histogram of the same data. Now what do I see? On my x-axis is the number of texts. That's the thing that I'm measuring, not the date. Okay? Your x-axis needs to be these numbers that you see here. Okay? The thing that you're measuring. The y-axis is how frequently do those numbers appear. Okay? So the histogram is going to ignore the date. Okay? It doesn't use the date. These dot plots, histograms, and stem plots show univariate data. They only show one variable. This date, that's another variable, and it's not going to show those things. So what I see here is, okay, my average day, I'm sending about 7 texts. Maybe a little bit more than that. Okay? On this, I could probably get that same, well, it's a little hard to see exactly where the center is. Okay? I don't know what this is called. Now, if I put little dots in the center of the top of each bar there, and then I connected those dots, and then I took the bars away and I put lines there, now I have something that I know what it is. This is a time plot. Okay? So now I can see, okay, I wasn't sending that many texts, and I didn't send many texts at all. I think maybe my phone ran out of batteries that day, and then boom, here I needed to talk to one of my kids a lot, and so I was sending a lot of texts those days. Again, I'm making this up, but you can imagine. So the time plot can show you different changes that are happening over time, and that's something that a histogram is not going to tell you. But a histogram is going to be very good in showing you the center, the spread, what's the minimum, the maximum of the number of texts I'm sending, the general shape of the data. So it's really, it's showing you 2 very different things. Okay? All right, well, that's it for this video. In the next video, we're going to be describing distributions numerically. That is, we're going to look at center, spread, shape, unusual features, and we're going to be much more specific about them we're going to be measuring them numerically. All right? See ya.